What I want to be going through today is paper 1. So that's mainly the stuff in mainly the code, but there's also a section on theory. I imagine we'll do the theory secondary to the code because the code is probably more important. But contrary to kind of how we approached it last year, the best way to tackle the code is not to focus on all the improvements you can make. It's better to understand how the code works and use that, because most of the questions are basically about extending the functionality as opposed to making corrections in the code, because nothing strictly in the code is incorrect. So once you know how the code works, once you know where the different pieces are and the different subroutines, you should be able to edit it and add to it and do whatever pretty easily. And I'll show you some examples of questions they might ask you to do based on the specimen, which don't seem too tricky. I guess we'll just wait for Reggie now. All right. What's a good joke? Elevator music. What do you call an epileptic lettuce? A seizure salad. What sort of shape is an escaped parrot? Polygon. Oh, thank you. I've been working on it. Nice chest hair. So, how's study leave going, guys? Bring out the spinner. Where'd it go? Do some. That didn't work. Nope. I can't balance it on my nose. Nope. There's a very big fly in here. I can't do tricks. It's not big enough. My computing textbook. Yeah. Start with that. 35 to 45. All right. So on, yeah, because the main thing to consider with this code is it's, as opposed to last year's, it's entirely object-oriented in terms of the coding style. So if you do have your textbooks with you, like you should always as you prepare for class, chapter 6 or pages from page 35 onwards basically tells you everything you need to know about how object-oriented program works. I'll go through it as we go through the code, but that might be useful to look at, to reference. Is what's happening with Ragib? What's going on? Because I want to start. 2 mins said that 10 minutes ago. What? 1 minute now. I can't think of any good jokes. What I want to be going through today is chapter 6, or from page 35 onwards, basically tells you everything you need to know about how object-oriented program works. I'll go through it as we go through the code. Page 35. What's the page? There's a disturbing avocado emoji. Ragib does in the conversation, yay. Right. Ragib's not here yet. Is he? But he's not in the call. Oh. Is he in the call? Stop sending various memes. Okay, I'm just going to start now. I don't care about anyone else now. Right. Also, if at any point you feel like you need to say something, you can try and say something.
Morning, lady.
Hello, Daniel. Everyone else is muted.
Oh, that's depressing. Pardon? Oh, hooray.
All right, let's start.
Oh dear.
So, if you do have your textbooks, then check Chapter 6 for object-oriented programming. The basic principles are... Are we starting? People are still talking. Right, so the basic principles are you have classes that you create objects from, and each class has a property, set properties, and all of the inherited objects share those properties and methods. So when you're talking about objects, every object will have properties and methods. Properties mean variables, like integers and booleans and things, and methods mean subroutines and functions and things. What's that? Computing textbook. Ah, very useful. Right. So this will help me illustrate my point. The basic idea is that if it will load, page 60. I'm just going to wait for that to load up properly. Right. If that book loads, then we can use it. So this idea is called encapsulation, which basically means is the concept that you have properties and methods, and they come together and they form an object. So an object of a class is, for example, in this code, whenever a new rabbit, a new warren, or a new fox is generated, then that is a new object. And every rabbit shares the same properties. Every rabbit has an age, every rabbit has a default lifespan, etc. They might be different, but they're all one of the same object. So let's start actually analyzing the code. Right. Does everyone have the code with them? Maybe I should just bring it up. Oh, this is nice. Right. Okay. Whose microphone is on? Right. Here's the code. So starting from the sub main, you can see here it's not very long. And this is like the main bit of the code, controls most of it from there. People keep saying things in the Skype chat. Can you explain what it does first? The code is a simulation of rabbits and foxes, where you have warrens of rabbits on a grid, and foxes are also placed in the grid. The foxes eat the rabbits try to reproduce and survive, and the ultimate aim of the simulation is to either have all the foxes die out or all the warrens die out. Now I want to see people for questions, but I can't, can I just have the chat? Is that possible? I'm just gonna share it. There we go. So let's go through the code. Module predator prey, and we start with the sub main. So the first thing the code will do is it defines these various variables. So menu option is as integer. This is the choice for the menu that the user will select. Landscape size, this is how big the user wants the board. The initial warren count is however many warrens the user wants in the game. The initial fox count is however many foxes the user wants in the game. The variability, this is a bit more complicated. I think the default value for variability is 0. And what it does is whenever the program generates a random number, it generates it using the variability, and the higher the variability is, up to 100, is the higher percentage chance that things go a bit crazy, basically. You'll see where it comes into play later. Fix initial locations as Boolean. So what happens is if you use a default simulation, then fixed initial locations is true, and that means that the initial locations of the foxes and warrens are preset, and that'll come into use later, you'll see. Right, so the first thing it does is displays the menu, right line, predator simulation menu, space, run simulation with default settings, run simulation with custom settings, or exits. Those are your 3 choices, and says select an option. So the first thing the user can do is input which choice they want, and then you have an if statement that decides what to do with that. So option 1 being the default settings, then it sets the, okay, what is it, Abdul? Cint. Oh, okay. Cint is a conversion statement. So it converts whatever the user types to an integer. So that avoids any crashing or any problems due to kind of improper data types, for example. So if you typed a string of characters, it'd convert them to integer because the menu option is an integer, and that would just be a 0. So it'd ask you again. So yeah, that's just validation. So if the menu's option is 1 or 2, if it's 1, then it sets the default settings, which means you don't have to enter any of them yourself. So it sets the landscape size as 15, so it makes a 15 by 15 grid. The initial warren count is 5, so there are initially 5 warrens. Initial count is 5, there's initially 5. Variability is 0, and the fixed initial locations is true because we want the foxes and warrens in preset locations. However, if the menu option is 2, it's exactly the same, except the user gets to input each time the variable. So landscape size equals cint, again, that's validation for a number. So a size of landscape gets to find the number of warrens, gets to find the number of foxes, and the randomness variability %, so that up to 100. There's no validation here, and it has to be an integer, so perhaps that could be something that fixed if it truly is a percentage up to 100. And then that ends it. So then what it does is it dim sim as new simulation, and passes those variables through. So sim simulation is a class that you can see here, and is so yeah. This is an example, our first class, and this is an example of instantiation. Instantiation basically means creating a new object from a class. So in this case, the simulation class is there, sim is the object, and is defined as a new simulation. What happens is whenever a new simulation is defined, this subroutine is, okay, wait, what is it, Ruben? So if you have your textbooks open, instantiation is whenever that it says new, whenever it says x variable equals new class variable. So I don't know if it's, yeah, it's on page 41 of the textbook, and it's instantiation, the process of creating an object from a class. So here, dimsim as new simulation sets, that's instantiation. Cool. Right. Yes, dimfox's new animal would also be instantiation. Anywhere it says new. And when anything is newed, when new is called, yeah, whatever. So whenever anything new is called, then within that class, the new subroutine is run. So every single class has a public sub new, and public sub new runs every time a new object is created. So for some classes, it will be a very short thing where it just sets up the object with some basic stuff. But in simulation's case, it basically runs the whole program from this sub new routine. So what happens is it passes through the landscape size, the initial Warren count, initial Fox count variability, and fixed initial locations, and it comes through to the new subroutine here. And that's very nice, that's very good. And what it will do is it will define, this is a little complicated, but what it does is it defines its own versions of some variables. So first it finds its own defines its own menu option, which will be the user's input, because it will display new menus for this when it's doing that. What is it, Daniel? This message has been removed. Right, so by ref and by val. So by value, that doesn't really come into the code here, but by value just copies the value across, whereas by ref, if you change it within the subroutine, it changes in memory. So if you're using by val, then you can change it in this subroutine, but then if you use it outside the subroutine, it will be the previous value unchanged. But by ref, if you change it in the subroutine, it will be changed throughout the whole code. Arshav is typing. Yeah, that's a good way to think about it. By reference, like reference the source or whatever. So yes, this submenu runs and it defines the menu option for the user, dim x, dim y. Don't worry about these, you'll know what they are later. Here's where it gets interesting. Me.landscape equals landscape size. So basically what it's doing is, up here, the simulation also has defined several variables, and it's defined a variability within this class. However, we also defined a variability up here as well. So what happens is, the variability, whenever a class refers to me.variability, that means the variability within that class. So me.variability means this variability equals variability which has just been passed through here by val variability as integer from the previous submain. So what it's doing is it's just basically saying my variability is the same as the variability that the user initially put in. So it's just transferring it across. And the same thing with landscape size. And yeah. Right, so here's where it gets interesting. Landscape equals new location. Again, we have instantiation. Remember, instantiation every time we see a new. And this time it's for the class location. What is location? That's up here, which is this tiny little class between the submain and class and simulation class. What a location is effectively, so when a new one is called, you have no fox equals nothing, warren equals nothing, and it defines fox as fox and warren as warren. What that means is within the locations in this code mean that they can contain either a fox or a warren. And it's initially saying that fox equals nothing and warren equals nothing. So there's initially no fox or warren in that location, but it's basically just setting up for what we're going to do later. So first it defines landscape equals new location. Sorry, not that. So first it sets landscape as landscape as new location, and it makes an array of landscape size, landscape size and landscape size. So that's making our grid that we're going to use later, because the user put in their landscape size earlier with, like, say 15 is the default, so 15 by 15. So here's an array defined by 15 by 15 with no array values. I think that's something you need to look at the rest of the code for, and you'll get what the location thing is. So the next line of code, create landscape and animals. So this is a separate subroutine, which we have to go down a bit for. There we go. Subroutine, create landscape and animals. So what happens here is it's passed through a series of subroutines from before. It's passed through the warren count, the fox count, and whether there are fixed initial locations, so whether it's default or not. So what it does is, this is where it properly sets up the board. So we've got for x equals 0 to, so these four statements, these recursive four statements, for x equals 0 to landscape size minus 1, for y equals 0 to landscape size minus 1, landscape xy equals new location. So what this does is it cycles through every location in landscape. So we've set up landscape as a two-dimensional array, or grid. So that's, if it's 15 by 15, it'll increment and go through each individual cell of that 15 by 15 grid, and it will make it a new location. So remember, a location class was whether a location class sets up that cell as having either foxes or warrens, and then this subroutine here goes through and individually assigns each cell as a location. So each cell can contain foxes or warrens. And here's where our fixed initial locations comes in. So if fixed initial locations, which was our if you choose the default option, then it creates new warrens at these locations and new foxes at these locations. So these would be the coordinates. So in the default program, the coordinates are the same every time for the foxes and warrens. So landscape, so in plot 11.warren equals new warren, landscape 210.fox equals new fox, and and that's what happens. And it sets the warren count as 5 and the fox count as 5, because that's how many there are. I think it's probably worth, we'll go to the actual warren thing now and see what it is like to create a warren. Here we go. So again, every time a new object of a class is called, such as class warren, a sub new is run. So whenever there's instantiation, whenever it says x equals new warren, we now have the public sub new run. Except this time we've got two public sub news. That's a bit strange. What's happening here is there's a separate one for two different circumstances. So you'll notice in the first one we've got bival variability as integer, And in the second, we've got byval variability as integer and byval rabbit count as integer. And what happens here is if the code calls for a new Warren and it only passes through the variability, it'll execute this sequence of instructions, and if it passes through variability and rabbit count, then it'll execute this series of instructions. So let's see what we did back here when we created our new Warrens. They pass through the variability and a rabbit count. So the only reason there are two is because if you're doing the default, then it wants to set up the simulation the same way every time. So it always sets it up as having these fixed numbers of rabbits already in the Warren. So when we go, did I miss it? So when we go and so when we do create it, we do this one instead. Later in the code, there'll be other opportunity to create new Warrens, and they'll use this part instead because they won't have a fixed initial rabbit count. So here, what happens is whenever a new Warren is defined, the variability is assigned. Again, this subroutine also defines its own variability and just make sure the variability pass-through is the same. So me.variability equals variability and me.rabbit count equals rabbit count. And then what it does is, this is a bit of instantiation inception, as the rabbits, it defines rabbits as equal to new rabbits and passes through this. So what happens is rabbits in this class is an array because it's got these brackets after it, which means it's been defined as an array, defined as rabbit, which is a class, which is further down. And so what happens is that array, the rabbits array, is equal to new, it basically sets up new rabbits, and then for r equals 0 to rabbit count minus 1, so for however many rabbits there are, rabbits in the array and the index being r, so it increments each time, will create a new rabbit and pass through the variability. So what we now have to do is go and see the rabbit class. So just a quick side note, this is an animal class, and both the foxes and rabbits inherit from the animal class. So you can see here is the class rabbit inherits from animal and does a variety of other things. And this basically allows the common kind of processes for between foxes and rabbits to be executed using the same kind of subroutines. So in this circumstance, so there'll be things like how the rabbits age and how the foxes age, and those can both be calculated using the same subroutines as found in the animal class. So here in the rabbit class, again, we have our subnews, and again, we have two, because there are different occasions when rabbits can be created. So what happens is when we were making new rabbits, we only passed through the variability before, and later on what might happen is you pass through the variability and the parent reproduction rate. Basically what happens is each rabbit has a reproduction rate, so the likelihood that they will reproduce with other rabbits, and when new rabbits are born, which happens, so while the code is running, when a new rabbit is born, it inherits the reproduction rate from its parents, as opposed to just being assigned the default, which is what happens here. So we're going to focus on this one for now anyway. So a new rabbit, so whenever a new rabbit happens, it passes through the variability. MyBase.new default lifespan. Right, so MyBase is a slightly complicated one. What effectively happens here is it because you've got two subnews, there's some trickery, and MyBase is called. I can't actually remember how this works, which is a shame. Yeah? Yes. Thanks, Arvind. You don't need to worry about MyBase because you won't probably need to code using it. Harshav knows more about it probably. What's he saying? Marvin Wang.
Typing. Basically, when you make a new instance of a base class, you will also have to make a new instance of all the parent classes, right? So you can't make a rabbit without, making an equivalent animal class to go along with it. And so you would, when you're doing a new rabbit, you'd also have to do my base to access the parent class, which is animal, and then instantiate that one too.
Yeah. What he said. Yeah, you should don't worry about that too much. Because I very much doubt you'll be asked to code it. Yeah. So, because there are various levels of class inception inheriting from multiple things, we've got that in my base. So, what happens is, so that sets up, and then the reproduction rate for a rabbit is now defined as the default reproduction rate times mybase.calculate random value. So that's calling the parent class, calling there's a subroutine in there's a subroutine in the parent class called calculate random value. I believe that's in the animal class. Here, sorry. And it passes through these variables and calculates a random value. So various times in the program, the foxes and rabbits need to have random values associated with them, whether it's mortality rate or whatever it is. And the way it does this is it's a function, so it returns the base value, which is what it passes through, minus base value times variability divided by 100, base value times blah, 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 blah. So there's lots of things here. Let's break it down. No way John's taking his clothes off. Oh my god. Alright. Yeah, so what we pass through here when we're defining these rabbits under default conditions is 100 and variability. Daniel's typing. Nope. What's enum? Enum is enumerated, yes, and it's defining a new type. So,
like Boolean, you have two options, yeah.
Yeah.
Like true and false. With enumerated, the value that variable can take are specified, and it can only take those, values. So you can only be male or female.
Yeah. So you basically create a new type of variable that has finite options, and then it has to be one of them, and then you can make condition statements based on those. So it defines gender as a new type, and that can be male or female. It could have just been Boolean, or it could have been anything really. There are a million ways to do it. No, I doubt they'll make, but we'll have to make transgender rabbits. Although that's possible, really, in considering it. They might ask to add another gender or something. But yes. Yeah. Yeah. What do you mean? Yeah. Oh, right. I see. Yeah, yeah. But yeah, okay. Yeah, because down here you can see an assignment for it. So gender of a rabbit is the enumeration is genders. So private gender as genders. So it defines. Ruben says it doesn't make sense. So gender here is a data type, and it's defined as genders, right? Which and genders is an enumeration of these two possibilities. Ruben get it?
It's genders.
Yeah, so the gender of the rabbit is defined as the gender here, which is the data type genders. The
We're
variable
making a
is,
user-defined data type
Yeah.
called genders.
the variable is gender, the data type is genders. The data type here that the rabbit is defined by, which it will later be defined by here, gender equals genders.male. So genders is the data type. So you can either have genders.male or genders.female. But here a private data type is called gender. Oh, Shree's here. That's nice. Lol, Shree. Gang. Anyway, it's just semantics anyway. You don't worry about the name too much. Point is, it defines a data type that could be male or female, and it then randomly does that here, which I guess I might explain now. So, generates a random number, rnd.next creates a random number between the lower bound, which is 0, and the upper bound, which is 100. Creates a random number between 0 and 100. If the random number is less than 50, then it's male, and if it's above 50, it's female. So basically, it's just generating a random gender to be either male or female. And that's how a rabbit's gender is assigned. That's how God did it.
So basically, what they're doing is taking the variable gender and then giving it only a few options to choose from, right?
Yes.
Okay.
So
Okay.
so an enumeration just is defining a new data type. So it defines the data type genders and gives the possible states that a genders could be, and then separately it defines gender as the data type genders, and then can assign a rabbit's gender to be one of the genders. There's a lot happening in the chat right now. Can we break at 2 for 5? It's way past 2. Okay, we can break at 3 then. But we haven't got very far. Alright, I'm going to keep going for a little bit longer, and then I might have a break because I want to rest my voice a bit as well. Alright, I'm not looking at the chat anymore. So, right. So that generates a random number, and that assigns the gender. Right, and a random number is generated here for the reproduction rate. So the reproduction rate is defined as the default reproduction rate, which is made a constant. There are 3 constants here. So one of them is default reproduction rate, which is at the moment is 1.2. Right, I'm not. So default reproduction rate times mybase.calculate random value. So mybase refers to the parent class, which is animal, random number, and that assigns the gender for the reproduction rate. So and then the data way past 2. Okay, we can break at 3 then. It passes through 100, which then becomes base value here. So what we have is base value minus base value times variability divided by 100. Under default conditions, variability is 0. So that's just, so this part becomes 0. Plus base value, which is 100 times a random number between 0 and variability times 2. If variability is 0, again, it will just calculate a random number between 0 and 0. So that's 0. So that becomes, this part becomes 0 as well. Plus 1. So it basically becomes 100 plus 1 divided by 100. Wait, is that right? Yeah, so 100. Oh, so 1 divided by 100 minus 100. And that becomes the base value under default conditions. And then so that's like 99.99 times default reproduction rate times 100, which for common purposes. So basically, the default reproduction rate for rabbits using the default conditions is effectively the same as the default here. So it's about 1.2. What happens if the variability is increased is, you can see here that this becomes not 0, so base value, which is 100, times variability, which is a percentage, so it has to be less than 100. So let's say our variability is 50%, then we have 50 divided by we have base value times variability divided by 100, so 100 times 50 divided by 100 is 50, plus base value times a random number between 0 and variability times 2, so that generates a random number between 0 and 50 and multiplies it by 2, times it by 100, adds 1, and then and it divides. So basically, variability makes a crazy, wacky number that is bigger than, which results in this whole thing being either larger or smaller than a default. And that, so basically by increasing the variability, you increase the craziness of the random number generated, and that can make a reproduction rate that's higher or lower than 1.2. I think that's a bit confusing, but I think, yeah, it increases variance. So it makes the code more interesting, potentially, because if you have only 2 warrens, but they have a crazy high reproduction rate, then they might make more warrens very quickly, etc. Yeah, so that's what happens. I'm going to move on from that. No, variability is whenever a random value is calculated. So in animal class, there is the function calculate random value, which occurs when you're calculating the reproduction rate. But I think also there are numerous other things, and we'll go through them, and you'll see. Because the calculate random value function is used for multiple things, and that uses variability. Yep. Yeah, use it for food units and stuff. Right, where was I before? So this is the trickiness with the code. So we'd created our new rabbits, and we were creating our new warren. Why have you got 2 mouses on the screen? I don't know, is one your mouse? Wow. Someone's microphone's on. I don't know who it is. Their microphone's off now. Right. Right. If we can. Right. So that defines. So basically, what we were doing before was we had our warren, and it was defining new rabbits when we were setting up a new warren, and it was rabbit count, wasn't it? So what happens is we basically now have a nice full array of rabbits with variabilities, and yeah, isn't that nice? Let's think. So in a default simulation, the number of rabbits, while the rabbits themselves are sort of generated randomly, the only random part is really their reproduction rate. But because the variability is 0 in a default simulation, then they all have the same reproduction rate anyway, so they're virtually identical. And then, so we now have an array of rabbits of fixed size, all with the same reproduction rate. So basically, the same thing will always happen in the simulation. In the simulation, if you're using default. So Daniel's going, do you want to take a break for 5 minutes? Or would, yeah?
Hey John,
Yeah?
so whenever you run the simulation, will
Yeah.
it always have the same outputs? Will it always like go through the same thing every time, as in the predetermined?
If you use the default settings, I
Yeah.
believe it'll be basically the same because all the randomness comes from the variability, and because variability is 0, there's basically no randomness. You can test it for yourself if you run the default one a few times.
Alright,
Yeah.
cool. Thanks.
Tell another joke.
Should I look up some jokes, John?
Yeah, look up some jokes. Give me some material.
Wait. Oh wait, no. Alvin's recording this. Ah.
Yeah, we'll go through potential questions once I've gone through the code.
Hey guys, I was thinking like, cause John's helping us so much, we should like buy him something. Yeah.
Oh,
like a
guys, I don't want anything that you have.
Just give him. Oh yeah, Harsam as well, obviously. We'll buy them each a car.
That's a nice idea.
I thought you, no, you didn't want anything. It's alright, we'll get Harsam 2 cars instead. But yeah, we'll buy you a car, half a car each.
We're making good progress, I think, with the code. Most of it is like setting up stuff. Is there anything anyone wants me to go over again? Or anything? Or any questions? Well, it's recorded, so you can revisit it, Abdul.
Oh man.
I'm just worried that it's a bit boring.
No, John, nothing you ever do will be boring to us. But maybe if you showed a bit more skin, you know.
Shut up.
Just a suggestion, John.
That's so weird.
Oh no, I just remembered Alvin's recording.
Exactly. This is all on tape.
I forgot I set up so my voice doesn't come through the recording.
Oh well.
So there's gonna be like moments of silence when John's listening to Alvin and then John replies to that. Everyone's gonna be like, John, why are you talking to yourself?
Oh well.
What?
John's computer has a different PP.
Why is my name different on John's computer with a different profile pic?
Yeah, I know, yeah. I don't know why. Your name's like...
I can't change it on this, so you're gonna have to deal with it. Don't look at it. Look up. Yeah, that's right. Scroll.
What is that? How do you pronounce that?
Pronounce it.
Asian?
Zayan.
Oh, is that supposed to be Zayan?
It's like, it's not really, but it is. You get what I'm saying?
You use £sign instead of Z and $sign instead of Y.
Listen, I'm all about that money, baby. Alright?
Yeah, I can tell.
Oh yeah, Abdul, basically. Oh, sorry. Carry on.
No, I wasn't going to say anything.
Basically, Abdul, if you change someone's name on Skype to something that you set, but then they change their name to something else, it stays at what you set it as.
Yeah.
So you set my name to Zayan. That's why you see Zayan.
I just go with the default.
What about
I don't know about the profile picture, it's just what it is.
Yeah, wait, who's Theresa May, by the way? Is that...
That's Arvind.
Because I got a different picture for Arvind.
I've got the one you can like the two big pictures of Theresa May and I think that's Sanjeev. Is it
Yeah,
Sanjeev?
that's me. That's me. That's Sanjeev.
Is it you?
No, it's Sanjeev, but it's
Oh,
like
right, yeah.
conservative RPM. But then if you look at Arvind here, he's got a different.
I'm gonna go through pages 35 to 45 and related to the code. That's a good idea.
Vote Labour. Whoa, what is this propaganda?
Someone say vote Labour. Yes, please.
John, click on this,
Click on it.
Yeah. Can you hear that, John?
I did. Did you hear it? Can you hear it?
No, we can't hear from you.
Well, that was beautiful. Just don't vote Conservative. That's a good idea. I gotta say it.
You should make it feel more like a computing lesson. Yeah, start touching people up.
Right, let's go through. Let's hurry up and go through the code so that I can move on to things. I didn't get any jokes in, but oh well. Wow. Right. Okay, I'm going to pick up where I left off. Ricky was still typing. Right. So what we had there was we set up the simulation class, and then so after the simulation we went to create landscape and animals, which was a subroutine further down. We're in layers and layers of subroutines, and just as a recap, that's where we got to our fixed initial locations, where if you are using the default game, then it sets the positions of the warrens and creates new warrens, and we saw what happens when you create a new warren. Now let's have a brief look, because it's basically the same, what happens when you define a new fox. So here we go, new fox, and foxes are very, very similar, that's why, because they both inherit from animal, so fox and rabbit is quite the same, and this one only has one subnew, which is useful, which only has a variability. So what it does here is, mybase.new, again, the mybase thing, because it inherits from other class, so pass through those variables there. So, foods units needed. That's the main difference. Foxes don't have a reproduction rate because they don't reproduce. Instead, or maybe they do. No, I don't think they do. Oh yeah, they do. Sorry. Foxes do reproduce, but they don't have a reproduction rate like rabbits do. Instead, we have food units needed, and food units needed represents basically however much food a fox needs. Yes, Ruben? Yes, I do know there's a reproduction rate. No. The user sets the variability if they don't do the default. For each, like, you can't set the reproduction rate for every single rabbit. What happens is it randomly generates the reproduction rate based on the variability. So the higher the user sets the variability, the more likely the reproduction rate is to vary from the default. Yeah. Right, so foxes require food units, which they get by eating rabbits, which we'll see how that works in a little bit. And basically, the food units needed by a fox is, again, determined randomly using the same subroutine. So mybase.calculate random value. Yes, Shri? Nope. So converts to integer.
It's just quickly. In the function reproduce this period, I think there's a kind of you do work out a probability, but you don't actually use it. You just say yes, true or false. So yeah, that's it.
Okay. Cool. Yeah. Well, yeah, we'll see that in a minute. All right, bye, Ragib. Nice seeing you. Right, yeah. So anyway, food units needed. So what happens is if a fox doesn't get enough food units, it ages by 1 unit, by 1 year or whatever. Basically, what happens is foxes start out with a lifespan, usually 7, and I don't think that changes. So each fox has a lifespan of 7. If the food units consumed is less than the one's food units needed, it ages by an extra year. So every time you advance a time period, it ages by 1. But if it didn't get the food it needs, it ages by an additional 1, so 2. And that basically means it dies quicker. So instead of having just it starve to death, it just ages quicker, which is quite good because you don't have to do a lot of extra coding for it. Yeah, so a fox is just set up with having however many food units it needs, which is a random thing. If you're using a default, it'll always be the same. Right, so there we go. We've set up our foxes, we've set up our warrens. Abdul's got a question. Yes, it does age quicker. The fox, what do you mean? When the fox doesn't get enough food, it ages by an additional lifespan unit. Where was it? Yeah, I think if it doesn't eat any food, it might die as well. We'll see that all later. Don't worry about. If I'm saying things, it might turn out what I'm said is slightly wrong because I don't have an eidetic memory for this code. But we will go through and we will see everything that happens, and you will understand it, and it will be fine. Right. So if fixed initial locations, and then so if it was the default, we've set all these things. Otherwise, then this happens. So this is if the user has put in their settings, then what happens is for W to initial warren count, which the initial warren count was set by the user. So for however many warrens the user wants, create new warren. And the same thing goes here for foxes, so create new foxes, and that's the end of that subroutine. So let's have a quick look at how warrens are created. So within the is it here? Oh, you know what? This will be easier. There we go. That was easy. Sub create new warrant, which is actually right below it, so I should have seen that. Never mind. So what happens is instead it goes through a whole process to create a new warrant instead of just defining a new one at its location. And what it does here is it generates a random position on the board for it to occupy. So it defines x is integer, y is integer, creates x. Yes, Abdul? X, so is that, yeah, so this is all if it's not default. So what happens is, so if it's default, these foxes and warrens are made. If it's not, then it creates it, then it goes through these processes and it iterates however many warrens you want and however many foxes you want. So what happens here is when it creates a new warren, it generates a random number between 0 and the landscape size, so somewhere on the grid, and y, so the y coordinate somewhere on the grid. And here's some confusing syntax. Loop while not landscape dot warren is nothing. So that basically means, so let's remove the negatives. While landscape is something, then do this. So if in that landscape plot, so you've randomly generated an x value and a y value within the grid, So if that location within landscape is something, not nothing, then you can use it. Then don't use it, sorry. Then loop again. So loop while that's true. So basically, so this is the do, this is the loop. So it keeps iterating this until you have a set of coordinates that are not occupied by anything else that's empty. So it loops while there is something there. If there's nothing there, then it moves on. If show detail, then this. Okay, so what will happen is show detail is a Boolean that is used when you're in the secondary menu when it draws it out, and when you get to choose how you want to advance a time period and if you want to show detail or not show detail. We haven't even got to that bit yet, but what happens is new warrants can still be created later on in the program. So if show detail is activated, then it will display this quick message saying that a new warrant was created at those coordinates you just selected. Don't worry about it now. We'll get onto that. And then, so yeah, after it's selected, it's random coordinates, landscape xy.warren equals new warren, and it does the same thing. No, show detail is false by default. So it won't. Oh, maybe it's true. Hold on, I need to check that. Show detail is false. Yeah, it's false by default, definitely. And then the user has to select it as true by selecting which option they want from the second menu. Not okay, right. So Ruben is typing. Do you think we should do potential questions on a different day? No, I don't think so, because okay, I think we'll have, once we've looked through the code and once you've got an idea of what it is, if you just look at the questions, like I won't tell you how to answer them necessarily because there are no real sample questions for this. There were some that Arvin sent, but I've looked through those and they're not especially good. But we'll just have a quick review of them afterwards, I think. What is your idea, Zayan?
Maybe, right, it's just a suggestion. So like after you've gone through the code and everything, maybe we can split into like two Skype groups of like 5 or 6 or whatever. I'll shove in one, John in the other, and then we like go through
Yes, good, actually.
coding, and then like if you get stuck, you can like ask one of them, and there's not too many people.
Yeah, but it might be easier to split. That's a nice idea, Zayan. I appreciate you. I like that idea.
Appreciate you, Zed.
Appreciate, yeah, Papa bless.
Off of that.
Yeah, so we've got the zigzag answers and stuff. The ones that Arvin sent initially aren't the greatest because like they're a bit different than what's in the specimen, but we'll have a look. Shut up, Zayan. Right, moving on quickly because I want to get through this. Yes, so that, and then what it does is, so it's generated its random coordinates, said that there was nothing in there, and then if there's show detail, it'll display a little message, but that comes later anyway. And then, so landscape, our two-dimensional array, xy.warren equals new warren. So the location within landscape is set as a new warrant, and we've already seen what happens when you generate a new warrant, which is what we just went through before, and the warrant count increases by 1 because a new warrant has just been created. Hooray! So that's what happens here after we create a new warrant, and then when we create a new fox, so that will loop several times, creating however many warrants you want, and then when we create a new fox, go over here, and it's basically the same thing, does exactly the same thing with x and y, generates a random coordinate. You could probably streamline this and make it like one process. While not, so yeah, same thing. If there's nothing in there, then, and if show detail, then write new fox at blah, blah, blah. Otherwise, creates a new fox, which we've just been through, and the fox count increases by 1. What is it, my son, Abdul? Well, that's a potential thing they may ask you to correct. Who knows? What do you mean? Like, usually, well, if you've got a 15 by 15 grid, that's 15 times 15 places on the grid. That's like 225, is it? Anyway, it's a lot of places, and usually the Warren count and Fox count is like 10 or something. I'm going to have a really quick go at making a 15 by 15 grid with 200 Warrens in it and 200 Foxes in it, and I'm going to see what happens. Yep, it fills up and it's crazy. I don't know if I can show it. Look at that, isn't that crazy? Can you see that? The grid's filled up. Anyway, so maybe that's an error that can be corrected. Yeah, I'm glad you all agree. You can't see? Don't worry about it. Try it yourself if you want. But basically the whole grid fills up with Warrens and Foxes, and that's not good, is it? No, sorry. It may crash if you put in far too many, but I just put in 200 Warrens and 200 Foxes. That's more places than there are on the board for each Warren and Fox. But I guess that didn't work. Anyway.
Well, you put 200 in, right?
I put 200 Warrens and 200 Foxes.
But it's 15 by 15.
Yeah.
That's 255.
Yeah.
There was 200 of each.
They're overlapping.
400.
No, because they can be in the same spot.
Yeah.
Right?
Oh, yeah.
They can be in the same spot. So
what if you have too many to even fit in the
right,
spaces?
okay, I'll try that then. Have a quick look. Yeah, the code doesn't have much validation, so there probably will be a one validation question. I'll go through the types of question you'll see, and I'll show you. Landscape size 15, initial number of Warrens 500, initial number of Foxes 500, 0 variability, and the program crashes. So there you go.
What if you do like the exact number that can fit in, like 250?
Right, I'll make a 10 by 10 grid to make it easier.
That'd be helpful.
Initial number of Warrens is 100. Initial number of Foxes is 100. And 0 variability. And it just fills up every grid with a Warren and a Fox. No, what happens is... So when it's generating these random ones, what it does is it says landscape xy dot Warren or landscape xy dot Fox. So if the dot Fox, so if in that location there is no Fox, then it will proceed, but it doesn't check if there's a Warren there. So a potential correction could be make sure that a Warren and Fox don't overlap or something like that. It'd probably be a bit more elegantly worded. Regardless, so that's how it works. Anyway, right. So that's what happens when you create. Let's go back into this subroutine. That ends that subroutine. Hooray! Shree's got something to say. It's a wonderful kind of day. Can learn to work and play. And get along with each other. You gotta listen to your heart, listen to the beat, listen to the rhythm of the speed. Open up your eyes, open up your ears. Shree is still typing.
Abu, even if there's a Warren in the place, you can still put a Fox, but if there's a Warren in there, you can't put another Warren.
Yeah. So the program just crashes if there's too many Warrens. Oh, there's a meme. I don't know if Shree's actually saying anything. I'm just going to continue. Stop tone policing, Zayan. They're allowed memes if they want memes. Probably best not to, actually. Shut up, Zakia. That's censorship. Right. Enough. Shree's still typing though. So that was the subroutine create landscape and animals. So we created do you actually have something to say, Shree? You can say something.
Basically, sorry, I was trying to write, it takes too long. Isn't it that each cell in the Warren is like more of a, it has 3 or 4 different bits of space like allocated for it. So that's one for a fox, one for a warren, and things like that, right?
Yeah.
So when it goes through it, it checks for each one.
Yeah, I was going to move on to that when we because we're going to examine how it draws it next.
Yeah,
But,
I wasn't
yeah.
sure. Sorry,
Yeah.
I ended up writing way too much.
That's okay. Don't worry. We'll go through it. Right. So create a landscape and animals is done. So that's what happens here. Warrens have been created. So we now have our grid complete with all the warrens and foxes we want at the start of our program. And so that gets us to here, which is draw landscape, which is what we were talking about slightly. So draw landscape calls every time a time period passes because it draws the grid again, and it is here. Yay! This is a subroutine within the simulation class, and what it does is right line, time period, and time period. If you've got the code up, it might be useful to look at how the grid is drawn initially, just so you can see it. So this is all just spacing out and formatting. For x equals 0 to landscape size -1, if x is less than 10, write a space, and if console.writeLine x and line. So what this does is, so this is writing out the columns. It would be so much easier if you could see this on, but basically it sets out the columns. So the initial column has a 0 and then a line and then a 1 and a line and a 2 and a line and a 3 a line, and there are several spaces between them. If the reason that it does this, if x is less than 10, then do a space, is because if it's a 2-digit number, obviously it takes up 2 spaces on the column header, otherwise it just takes up 1 space. So if it's a 1-digit number, it does an extra space. And then it writes a line between each number, and then a space, and a line, and then the next number, and that repeats until all of the columns have been written out. Then it writes a line, and then for y equal to landscape size -1, if it also writes these for x equals 0 to landscape size times 4 plus 3. Write these little dashes. So there's a line of dashes separating the column header from the rest of the table, and it calculates however many. Obviously, the number of dashes isn't proportional to the number of columns, but it apparently is proportional to times 4 plus 3, which is nice because four dashes fit over every column and 3 fit at the start. Again, this is all formatting. You don't really need to understand how this works. Console.writeLine. And then for y equals 0 to landscape size, if y is less than 10, again, you write a space because if it's a 2-digit number, it doesn't need that extra space. Console.writeLine, console.write space, and y and dash. So what that does is, so we've had the numbers written at the top, now it's writing numbers down the side. So so initially y is 0, so a space, y 0, and then a line, and it'll have that all the way down. But further along the line, it says, right, so for x equals 0 to landscape size -1, so for however many spaces there are on the landscape, if not landscape.warren is nothing. So again, the nothing means something. So if there is a warren in that landscape, then if the rabbit count is so if there's a warren in that specific location, and then another if statement saying if its rabbit count is less than 10, then write a space, because what it does is it writes instead of writing just a warren, it writes the specific number of rabbits in the warren. But obviously, if the rabbit count is less than 10, then it will write a space, because again, it doesn't have 2 digits, it only has 1. So to keep the formatting correct, it just writes a space, and then console.writeLine warren.getRabbitCount. So getRabbitCount is a function that just returns the rabbit count of the warren. I don't think I need to go through that. Then it writes a space. Else write 2 spaces. So if there is no warren, don't write a number, just write 2 spaces. And then in the third kind of line of each cell, if there is a fox, again, if not landscape.fox is nothing. So if there is a fox, then console.write f. So it's quite a clever system because each column in the table. Okay, I can go through that again. So Ruben, have you got the code up with a example of a table? Yeah. So what you can see is all of this is just all of this is just kind of formatting the design of the table. So you've got the columns and then the dashes and then like each row and stuff. Yeah, I mean on the computer. Okay. Don't particularly worry about it. Wonder if no, I can't do that. I don't think you need to worry about this much. You could replay this part and check while you're looking at a computer copy. But it all formats it, and basically each in the table in the grid, each cell it has 3 spaces. The first 2 spaces are reserved for a two-digit number representing the Warren count, and that's a nice timestamp. And the third digit space is reserved for whether there's a fox or not. So what it does here is, moving on to the next digit, if there is a fox, write F. If there isn't a fox, write a space. And then it writes a dash, so there's a dash between each, and that's how the structure of each line goes. So it basically is just a recurring thing where it draws out each part. If there is a Warren in the space, it writes the Warren number, the rabbit count of that Warren, and if there's a fox in that space, it writes an F. Yes, Abdul. So each column, there are 3 spaces in each column. The first 2 spaces are reserved for whether if there's a Warren there, and it will write the Warren the rabbit count in there. Else, it will write an F for fox or nothing at all. Now, you know, like there can be many rabbits in one space of the grid. There can be...
The reason that the more than one rabbit in a space in the grid is because you don't actually draw the rabbits, you're drawing the Warren.
Yeah, so the rabbits are contained within a Warren, and it displays the rabbit count, so the number of rabbits are in that space. But foxes don't live in Warrens, they live on their own because they are sad and lonely. Yes, the limit is 99 because that's the biggest it can display. And when we see it generate, we'll go back and generate when it generates random ones, and you can see. I didn't see what he said. So only one fox. Yeah, so there can only be one fox in each space, and there can only be one Warren in each space. But the Warren, the number of rabbits in a Warren can be anything up to 99. Wait, in my code. So that means that in that cell, there are 24 rabbits in a Warren and also a fox. Not 24 foxes. No. There are 3 spaces.
As in, like, there's 3 like character gaps, 2 of which are assigned for the number of rabbits, and then one of them is for the foxes. 2 things up go in there, but there are 3 character spaces in terms of the formatting.
Yeah. Right, everyone happy? Yay. Right, so that's how it draws it. Don't worry too much about how it draws it, because that's kind of just all formatting stuff on a console screen. Aaron has something to say. No, he doesn't. Okay, so so now what we've done is we've set up our grid, our 2-dimensional array. We've assigned rabbits and foxes randomly to it, forgot to plug the MacBook in. Yeah, and now we've even drawn it so the user can see what's going on. So now what happens is we display our next menu, which is what happens, and it says, so now you see your landscape spread out. You can either advance to the next time period showing detail, advance to the next time period hiding detail, inspect a fox, inspect a warren, or exit. And just like the last menu, reads in the user's input, read console.readline. What do they mean? So what happens is we're going to go through the code for advanced time period. That's the biggest chunk of code, really. And so when it shows, if you show detail, then basically every time a rabbit or a fox changes. So if rabbits eat, if a fox dies, then it will say this fox died. Or if a rabbit, or if a warren dies out, it'll say this warren died out. Or if a new warren's created, it'll say a new warren's created, or whatever. So it just puts in all the information that happens within that time period. Otherwise, you can just advance without showing detail. Yeah, tells you the status of the foxes and warrens. So, or you can just advance to the next time period, and it will just display the board as is. All right. So inspect. What happens is, well, we'll see what happens. In fact, I won't go through that just yet. I'll show you what happens when we inspect. Yeah, this inspect shows you the status of a particular warren or fox that you want to look at. Basically, all the information you need to know. We'll go through that there when we go through the menu options. Okay, bye, Aaron. Have a nice day. Right. Yeah, there's an inspect subroutine that we'll go through in a bit. Right, so let's just go through the first menu option now. So if menu option equals 1, then period, someone's mic's on, plus equals 1, and show detail becomes true, and then it executes the subroutine advanced time period. The menu option 2, the only difference is this show detail boolean is set as false. So initially, so by default it's set as false, but if the user wants to see the information, it's set true, and all of the things where it could show detail are dependent on that boolean. So let's just see what advanced time period says. Yay! Here we are. So this this basically codes for everything that happens between the time periods. So this includes where the fox is eating, whether the foxes die, whether the rabbits die, whether the rabbits reproduce, whether a new warren's created because the rabbits are reproducing, etc. And that codes all this stuff. So let's get into it. Dim new fox count as integer equals 0. So defines that as 0. We'll see what that does in a sec. If show detail, then it writes a line just for formatting. So what it does now is for x equals 0 to landscape size -1, for y equals 0 to landscape size -1. So basically, for every location within the landscape size, every location within the landscape array, if, again, it's that nothing thing. So if there is a warren there, y -1. So you'll notice when you go through, each one is -1. And the reason is because you input a landscape size. So I say I want to do a 15 by 15. So I put my landscape size as 15. But what it does, but we're coding from 0 to -1. So the landscape size when I put it in is set to 0 as the first one sort of thing. That's how it works. Anyway, I think, yeah, you get it. Right, so if there is a warren there, and then if show detail is true, then console.writeLine warren at blank, console.write period start dot inspect. Right, so this is where the inspect comes in. So what it will do is it will cycle through. So for every warren that is there, it will say there is a warren here, and at the start of the period, this is what is happening. So if we go to inspect, going to just jump to it. There it is. Inspect literally just is one line of code that says console.writeLine periods run and size and rabbit count. So in text it types periods run, and periods run is a variable that increases by 1 every time there's a time period. It'll be up there somewhere. So if this is the first time period, it'll be 1. If it's the second time period, it'll be 2, etc. So it tells you how many periods have been running, and and then size and rabbit count. So what it looks like if you write it out is time periods run to size 15 or whatever. So it just gives you the information basically, and that's what inspect does. Where was I? I don't know where I was. I was in advanced time period, which is here. Yeah, so that's what happens. It tells, so at the start of the period, it tells you the size of the warren and the number of periods that the warren has been alive. Isn't that great? And then it will check through, so it's checking through the whole landscape. So if there's a warren there, then, and if the fox count is greater than 0, so if there are foxes on the board, then fox eats rabbits in warren. Fox eat rabbits in warren XY. How does that work again? Right, so we are still checking through. So if there is a warren here, then all this happens. So if there is a warren there, then it executes this subroutine, which I believe determines the number of rabbits eaten by a particular fox. So I'll find that subroutine. What was it called? Fox eats rabbits in warren.
I think it's just in simulation.
Is it?
Like it's not a class specific thing.
I couldn't find it anyway. It's a subroutine. There we go. Fox eats rabbits in warren. So what happens is you pass through the location as warren X and warren Y. Right. So yeah, this is the code for how it decides how many rabbits are eaten by a fox and how much food a fox gets to eat. So dim food consumed as integer, percentage to eat as integer, dist as double. We'll go through all these variables as they come up. So dim rabbit count at start of period as an integer, which so it defines this as and basically for this it gets the rabbit count of the warren, and then for fox X 0 to landscape size -1. For fox Y, 0 to landscape size -1. So it defines fox X and fox Y as just 2 X and Ys. And then says, like the warren before, if there is a fox in this location, so checking through each location, if there is a fox there, then dist, which is short for distance, equals distance between fox X, fox Y, warren X, warren Y. Distance between is a function down here, and it basically finds the uses Pythagoras' theorem to find the hypotenuse between the two things. So we're on a grid, so if you find x squared and y squared root of, you've got the distance between two things on the grid. So here, Arvin's typing. Yeah, basically. And there are specific rules. So what it does, it determines the distance as math.square root. So it finds the square root of the change in x over the change in y squared Pythagoras theorem, and it returns the distance that the fox is. And then it says if distance is less than or equal to 3.5, then the percentage to eat is 20. If the distance is less than or equal to 7, then the percentage to eat is 10. Otherwise, the percentage is 0. So bear in mind, this is a single warren that we've picked out. So it's gone. It goes through each location, finds a warren, and then it finds a fox, and then within that it cycles through again and finds a fox, and it says it finds the distance between them, and if it is within 3.5, then the percentage it eats is 20%. Otherwise, the percentage to eat is 10%. Otherwise, it's 0. What if a fox is equidistant from 2 warrens? So it will eat from every warren. It's going to cycle through, and you'll see what happens.
What you do is you do warrens first, yeah? So you look at the target warren you're looking at, you would look at that, and then you would search for every single fox, and you see how much those foxes will eat from that warren. And then you move on to the next warren. So the fact that it's equidistant between 2 just means that it's going to eat the same amount from both. But yeah, you do one warren at a time, and then the next one.
So if a fox is surrounded by warrens, it'll eat from each warren and get way too much food. Who knows? You might have to code in the fox dying from obesity or something. So it finds a percentage to eat based on the Pythagoras theorem hypotenuse distance. Rabbits to eat is then determined by finding. Right, it's a complicated mathematics equation. So hemorrhoid probability. Yeah, sure. So the percentage to eat. So for example, if it's 20% multiplied by the rabbits at the start of the period, so it finds 20% of the rabbits divided by 100, because that's a percentage anyway. So it finds a number, converts it to a double. It converts it to a double to use math.round, because math.round only works with doubles properly, I believe. And then it converts that to an integer. So it rounds the so math.round rounds it to a whole number, and then that number is converted to an integer, which is stored in rabbits to eat. So that's the number of rabbits that the fox will eat from that warren. And then the food consumed equals landscape warren x, warren y, so the coordinates of that warren dot eat rabbits to eat. So it executes another subroutine for the warren. So in the warren class, we have a function called eat rabbits, and so this is called, and what happens is the death count as integer equals 0. So it sets the death count, the number of rabbits that are going to die, and the rabbit number. We'll see what those mean. So if rabbits to eat is greater, so we've determined the number of rabbits that the fox is going to eat. So it was like 20% of whatever. So if rabbits to eat is greater than the rabbit count, then rabbits to eat equals rabbit count. So if there's only however many in the warren and the fox eats them all, then if it was going to eat more than there were there, then it just sets it as the number equal to avoid any errors. And then while death count is less than the rabbits to eat, so while the warren hasn't been completely wiped out, rabbit number is equal to random.next 0. So it generates a random number between 0 and the number of rabbits. And then if not rabbit number is so it's the not nothing thing again. So if within the array of rabbits within that warren, if there is a rabbit there at the randomly generated rabbit number, then the rabbit associated with that rabbit number equals nothing. So that kills the rabbit. So it says that space is nothing, and the death count increases by 1. And while and so that repeats. So each time, so if you need to eat 10 rabbits, basically, it generates a random number to assign death to a random rabbit, and then it selects that rabbit, and that rabbit becomes nothing, and the death count increases by 1, and once the death count reaches the number of rabbits that need to be eaten, it moves on. So if it was 10 rabbits, it will kill 10 rabbits and then move on. And then what it does is it compresses rabbit list. This is quite elegant. So what happens is you're not just picking off the first 10 rabbits to be eaten, you're picking out random rabbits from the list of rabbits. But then obviously you've got a problem because you've got a list with some empty spaces, and that's not very efficient, so it compresses it by basically removing the spaces. What is it, Abdul? Yeah? So yeah, after every time period, it calls draw grid. It calls draw landscape. I don't want to move that. I'm just going to check my paper copy to see where it does it.
What do you mean it has to draw it again?
No, because it draws the landscape after every time period. Yeah. So if you look at the what do you mean? It should. It does for me.
I'm going to run it as well. So what's he saying is that when you do...
It doesn't draw again. There's at the end of advanced time period, the second to last instruction is draw landscape. If you've shown detail, then you need to press enter again. Like you need to cycle through all the information. There you go. Right, moving on. So compress rabbit list, I'll quickly show that. Where is it? There, here it is, compress rabbit list. So this is just removing all the empty spaces in that list. So dim shift 2 is, again, just some random things. So if death count is greater than 0, so if rabbits have died, which is important for this, then it sets these variables as zeros, while shift 2 is less than rabbit count minus death count. So initially this is 0. So while 0 is less than the rabbit count minus the death count, because we don't want to kind of remove more rabbits than are needed. I know, hold on, I'll explain it better in a second. Oh, why can't you run the code, Ruben? Someone's mic's on.
Oh, that's not... if you want to see how variability affects things like reproduction rate, what you should do is change it, and then when you run the code, do it with detail, inspect the specific warren, and then it'll be like view individual rabbits, and if you've picked a warren that has like a decent number of rabbits, it will list all of them. So currently it will just show all the rabbits, and all of them will, have the same reproduction rate. But if you change the variability, that reproduction rate changes a lot.
Yeah. So that's how you run the code. Right. Zan's talking about something completely unrelated. Where was I? So, compress rabbit list. What happens is, so rabbit count minus death count, so the number of rabbits minus the number of rabbits died has to be greater than 0, which makes sense, while rabbits shift from is nothing, shift from plus equals 1, and while, you know what, I don't know if I need to explain this. It's I can't actually remember. Yeah, it just compresses the rabbit list, so you just need to know what it does. So yeah, so whenever rabbits are removed from the array of rabbits, they are compressed, and it makes the rabbit list nice and neat. Where was I? So advancing time periods.
Yeah, the compressing thing is what it does is it will scan from the start until you find like an empty space, or and then move it backwards, and then it just keeps doing it. It fetches them and keeps putting it, and you just imagine it's kind of like just packing it, go through the list and just move them all towards the left end, like the start end, and then eventually you run out. You get to the point where the max number of rabbits, and you wouldn't have anything past that point to compress. You'd stop.
Yeah. So compress rabbit list. I might stop going through things in such great detail. Anyway, you can rewatch it if you really didn't see. Where were we? Right, advanced time period. I can't remember where I was. All right, fox eats rabbits. That's where we were. So, yeah. So after fox eat rabbits, we calculated the number that it needs to be eaten. The food consumed was equal to the rabbits to eat, which we worked out, and then landscape.fox.give food. So this here actually gives the food to the fox itself. So if you go to the fox class, have a quick look at that. Give food basically means that it passes through the food units and says the food units consumed this period equals the food units consumed this period plus the food units. So adds on those food units from that warren that was from those rabbits that were eaten. So one rabbit equals one food unit. And those become the number of food units for that fox. So
that's like an example of functional programming where the actual food units eaten that time in the fox class is a private variable, so you don't want people to be able to edit it outside by accident. So you'd have to call this specific subroutine called give food, and that's the only way you can change it. And that way, if you constrain the way they can change the variables, you can't do anything that could potentially cause an error.
Yeah. Yeah. So, blah, 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 blah. That's what happens there. Fox eats rabbits. Where was I? And then, so it gives the food to the fox. The fox get those food units. If show detail, then it tells you however many food units that fox just ate from that warren. And then that's it. That's the end of that subroutine. So going back to advanced time period, so fox eats rabbits in warren. So for this particular warren, again, it will cycle through all of the warrens and check each time all of the foxes and whether they're close enough. And if they are, then it takes away some of the rabbits from that and then gives it to the fox. And then so after that's done, and then we've got the next bit. If landscape XY, so if this warren needs to create a new warren, then it creates a new warren. So this is another subroutine. Need to create a new warren. So this is a function that returns either true or false. So it checks whether it does need to create a new warren or doesn't need to create a new warren. So what happens is if the rabbit count equals the max number of rabbits in warren, which was set as a constant, so the max number of rabbits is constant at 99, and if it checks here, if it needs to create a new warren, then the rabbit count will equal 99, and not already spread. So already spread is a Boolean, which basically means once it creates a new warren, it's classed as already spread, which means that one warren can't make more than one other warren. All right, see you, Abdul. I don't know how much longer we're going to do this. I think 5 o'clock is probably my limit, but we'll keep going as long as we can. Try and get through all of it. Okay, see you, Ruben. Fairs. I'm not going to do it tomorrow if we are doing it tomorrow. Yeah, Harsha can do something if he wants.
Okay.
Right. I don't mind doing another day. I don't want to do 2 days in a row of this, though. Just so you know. Anyway. Right, so. Yeah, maybe Friday, we'll see. So, function needs to create new warren as boolean, rabbit mechanics, next one, not spread, then already spread. Actually, I can't do Friday, I just remembered, but never mind. Right, so, if it's already spread, then the the warren can't create a new warren, so it stops the warren spreading wildly, because once it reaches 99, obviously each time this iterates, it would spread to another one, but it limits it so a warren can only spread once. So if a warren has reached 99 rabbits and has not already produced a new warren, then it returns true, which takes us back to here where we advanced to time period. So if it does need to create a new warren, then it executes the thing we saw before, which was create a new warren, which we already went through, and it's the same process again. So this program's very good because it reuses all of the subroutines that it's got multiple times, and it's very efficient and blah blah blah. Very good coding, probably the best coding I've ever seen. Right. The next thing it does, so it's checked however many rabbits get eaten. It checks whether it's reached the maximum number and needs to create a new warren. And now what it does is it advances generation. So now it's going to age all of the rabbits. So if we go to the warren class again, advanced generation, that was lucky, wasn't it? Is this the one class? It is. Right, so what it does is it increases the periods run, which is within the warren. So periods run represents the however long the warren has been alive for, and is used when you're looking at the inspect data and stuff. So if rabbit count is greater than 0, then kill by other factors. So if there are rabbits within this warren, then it executes this subroutine called kill by other factors, and that basically there's a random chance that rabbits can be killed by disease or whatever it is. It's just a random culling of the rabbits. It sets a death count, and then it says for each rabbit within this warren, check if killed by the factor, which is within the rabbit class, I believe. Nope, it is not. Oh, it might be in the animal class. Nope.
What are we looking for?
Check if killed by other factors.
I just saw that. It's near age rabbits, isn't it? Yeah, it's above age rabbits.
No, you want just now, right there.
No, I want check if killed by other factors, not kill by other factors.
Oh, right. Oh, I could just do it. Yeah, that's in the start of animal. It's part of animal.
Oh, okay, yeah, it is an animal. Right, so this is the trickiness with the code, is that there is so much stuff, it's hard to jump around, but once you find it, you know what you're looking for. Right, so here we'll check, so presumably because it's in the animal class, foxes also need to check whether they're killed by other factors, and it's a Boolean, so it creates a random number between 0 and 100. The probability of death by other causes is determined whenever a new animal is made. So I probably should have done this before, actually. When we were going through before and saying sub-new for a rabbit and sub-new for a fox, when a new fox is created, the mybase.new, I just realized what this does, the mybase.new also calls the sub-new for the animal, because it's a subclass of animal. Did I miss it? Yep. So it also, whenever it creates a new fox or a new rabbit, it also calls this subroutine here to create a new animal. And what it does here is it determines a lifespan for it. So this is where the lifespan comes in. Again, it creates a random number, just like we saw before, calculate random value. The average lifespan is passed through, is it? Yeah. So that'll be passed through whatever. These numbers are all kind of tertiary anyway. So it calculates a random lifespan, calculates the probability of death by other causes. Again, all these things are done by create random value, which uses the variability. So there'll be in the default, it'll be the same, but you increase the variability, you increase the chances of being off. Is alive equals true, which is good. ID equals next ID plus equals 1. So basically it assigns an identification number for every single animal in the game and increases that by 1 each time. Yeah, that's how it works. So every animal will have an ID number that you could reference it by, or if you wanted to keep track of a particular rabbit in your warren, I don't know why you would, but yeah.
But the default lifespan for rabbits is 4, and the default lifespan for foxes is 7.
Thank you. So that happened there. Right, so we were checking check if killed by other factors. Right, so that happens. So, yes, Daniel? I don't think it comes. I think when you inspect a rabbit, or if you inspect an animal, it produces its ID. In fact, here we go. Inspect. It gives the ID of the animals and stuff. But yeah, there's no way to just bring out the ID specifically. But the ID is used sometimes when displaying information.
So there could be one of the things could be find a way to look up particular.
Maybe, but I don't think there's a use for that, because whenever you advance, if you advance a time period showing detail, then it and you inspect, if you inspect a particular rabbit warren, like Harsha's produced a picture there. I don't know if I can see it. Yeah, so it gives you the ID of each animal, as you can see here, which is useful. Thank you, Harsha. But there's no way to just pick out the ID of an animal and say, let me look at this ID, but you could keep track of it. Anyway, yeah, so that's what ID doesn't really do much. Yeah, so check if killed by other factors. Right, so probability of death by other causes was calculated when the sub-new ran as the average probability of death by other causes times a random value. So it's a random kind of percentage times 100. So you calculate a random number. So if it's less than that, then it dies, is alive, becomes false. And if it's is killed by other factors, returns true, otherwise returns false. So our fox was, we were checking if it was killed by other factors. Yeah, so within advanced generation, nope, that's for the fox. Killed by the factors here. So checking. So right, checks. So it checks for each rabbit if it was killed by the factors, and if it is, then that space in the array becomes nothing. So the rabbit's dead. Death count increases by 1, and it then does the same thing again, compresses the rabbit list. And if show detail, then it writes rabbit was killed. This rabbit here was killed by other factors, and that's that. That's nice and neat. Right, we were in advanced generation, weren't we, for a Warren? Advanced generation. So right. So there we go. We were checking. We increased our periods by 1. We checked if rabbits were killed by other factors, and then once those rabbits have been disposed of, if rabbit count is still greater than 0, so if there are still rabbits to be manipulated, then age rabbits. So what happens here is go down to age rabbits, and effectively find for each rabbit in the thing, it calculates a new age, which is done very simply. Calculate new age. Then it does is just increase the age by 1. If age is greater than or equal to natural lifespan, then it dies. Is alive equals false. So we increase. So if perhaps calculate new age, and then it calculates check if dead. I won't go to that one because it's very self-explanatory. Just returns true or false whether it's dead or not. And if it is dead, then that rabbit becomes nothing. Death count increases by 1. Compresses rabbit list again, and writes if show detail, then writes that. So that you can see there's like a very structured thing to this. Every time an animal dies, it does the same thing, increases death count by 1, compresses the rabbit list, etc. Right, so that's what happens. Yeah, so that ages our rabbits. Which was here, was it? Or it was advanced generation, that was it. So we've aged our rabbits, and if the rabbit count is still 0 after they've been checked if they've been killed by other factors and checked if they've died of old age, and the rabbit count is less than or equal to the max rabbits in Warren, then if contains males, so this again checks through I won't go through that one because that's again very self-explanatory. That routine, all it does is checks if there are males goes through and checks if there are male rabbits within the array, then mate rabbits. So this is where we get our reproduction coming in. So the mate rabbit subroutine, I won't go through those yet. So for each rabbit, if rabbit is female, so that just returns whether it's female or not, and rabbit count plus babies is less than max rabbit in Warren. So initially babies is set as 0, but it will increase as we loop through this. Do mate equals random number between 0 and the rabbit count, while mate is R or mate is female. So what we've done is we're cycling through the rabbits. So we've got so we're looping the R, which is our index for the rabbits array. So if the rabbit R, so if our selected rabbit is female, and we haven't got too many rabbits in the Warren yet, it will mate with a rabbit and will keep repeating. It will keep looping until it finds a rabbit that isn't itself and isn't another female. So it basically loops through until it finds a male, and then it finds a variable called the combined reproduction rate. So it finds the reproduction rate of each individual rabbit, adds them together, divides by 2. So it finds the average of the reproduction rates. And then if the combined reproduction rate is greater than or equal to 1, then the rabbit count plus babies equals new rabbit. So what happens is, right, so cycles through, finds if there are males within the array, then it comes to this mate rabbits subroutine, identifies a random, cycles through, identifies each female finds a random male mate. So a male rabbit could potentially mate with more than one female rabbit. So long as there are males, each female rabbit will produce offspring, so long as the combined reproductive rates of those two rabbits divided by 2 is greater than 1. And if it is greater than 1, it produces a new baby. So in the array of rabbits, with the index rabbit count plus however many babies there are, then it will create a new rabbit with a variability in combined reproduction rate. So what we saw earlier when we were generating our rabbits before was we were only using the variability, but now we're passing through the parent's reproduction rate, which we now use to determine that rabbit's reproduction rate. So reproduction rate now equals the parent's reproduction rate times a random value. And that's the only difference between those two subnews. So what we've done is we have mated our rabbits successfully, I hope. Pavan Kang is typing. Yeah, so each rabbit, if you use the default settings, each rabbit will have just 1.2, which is the default reproduction rate. But if you increase the variability, whenever a new rabbit is generated, its reproduction rate is randomly calculated, and then when a rabbit is born from 2 pre-existing rabbits, the parent's reproduction rate affects the reproduction rate of the child, and again the variability affects that. So the reproduction rate of a particular rabbit can't be changed during the course of its life. Each rabbit has an individual reproduction rate, and when a new rabbit is born or created, it's a reproduction rate for it is set individually. Is that what you're asking? I'll take silence to mean yes. Okay, cool. So it checks through. Each female can produce a baby. So it checks through to find another a compatible male. That male by finding random rabbits, and then it finds the average reproduction rate, and if it's greater than 1, then they create a new rabbit, which we've just seen. The babies increases by 1, and this whole thing loops until we've checked through the whole array of females. And that's what mating rabbits, how that works. Right, so we've checked if our rabbits were killed by the factors. We've aged our rabbits and killed the ones that are too old. We've mated our rabbits and added the babies to the warren. All right, so now if our rabbit count is 0, so if the rabbits were all killed off here and this never happened because the rabbit count wasn't greater than 0, then and show detail, then it'll say all the rabbits in the warren are dead. Convenient, and that was that. Right, so that's what happens there. That's what happens when you so that's advancing a generation within this. If you show detail, then it writes at period end. Inspect just returns the number of rabbits that are there, so it gives you an inspect at the start and an inspect at the finish for the number of rabbits that are within the warren. There's a read line. If landscape xy.warren has died out, so warren has died out returns whether the rabbit count is just 0 or not. So if it is, then the warren is deleted. That location warren equals nothing. The warren count is decreased by 1, and that ends if blah blah blah. advanced time period. That's the first half for warrens. Then there's a very similar second half for foxes, which effectively does a similar thing. So checks through this time for foxes, so each location in the array. If show detail, then writes line for each fox where they are. And now we advance a generation for foxes. So let's quickly check that. It'll be very similar to the one for rabbits. So advanced generation, right, so if food units consumed this period equals 0, then is alive equals false. So if the fox didn't eat anything at all, it dies. And if the show detail is there, then it will say the fox dies and has eaten no food this period. Else, if it has eaten some food, you check if killed by other factors, which is, I believe, identical. That's in the animal class. Again, it's the same thing as before. Actually, I was going to say something. How does ID get incremented?
The whole ID and next ID thing, I see that it goes up in the animal class.
Yeah.
But then this is
So so ID is integer, shared next ID is integer equals 1. So initially starts at 1. So the ID equals, so for the first animal created, ID equals 1.
But the thing is, like, this animal class is inherited by a fox, right?
Yeah.
But then, so when you do a new fox, right, it will take the ID of 1, I guess. But then the next fox, when you do new all of that, how does ID not get reset to 0 and next ID get reset back to 1?
Because, because it increases by 1. What do you mean? You think it's no?
It's not as a global variable, right? Like every time you
these
do
are protected.
Okay.
Protected variables don't change across each object.
Oh, okay. That's interesting. Okay.
Yeah.
Cool.
Arvin just typing. Yeah, effectively. So over all the objects of the class, those protected variables will stay the same value, or like they won't vary between each object.
Oh man, knowing that would have been so useful in the computing projects.
Oh yeah, I know. So yeah, that's that. Where was I? So we advanced the generation. Now we're advancing generation for the foxes. So if food units can do 0, then it dies. We check if killed by other factors, which is exactly the same for the as for the warrens. And if it was killed by another factor, then again is alive is false, and if show detail, then fox killed by the factor. So otherwise, if food units consumed this period is less than food units needed, then calculate new age. So this is what I was saying earlier. If it doesn't eat, so its food units needed were calculate. We showed earlier, and if the food units it ate from the rabbits is less than the food units it needed, then it ages, and then again after that it ages again. Here, calculate new age and calculate age. So basically ages twice. So calculate new age just increases its age by 1, and if it reaches its natural lifespan, then it dies. Adam is typing. He is not typing anymore. If show detail, then then you say, don't worry. So if you show detail, then say the fox ages further due to a lack of food, then it ages again. So if it did eat the food units, it still ages, but if it didn't eat the food needed, then it ages twice. And then if not is alive, so if it is not alive, then show detail, and if show detail, then fox has died of old age. So yeah, that kills the fox. There you go. So that advances. That's what happens when the fox advances a generation.
If it doesn't eat any food, does it die instantly?
Yeah, no food means death. Less food than needed, but still some means it ages twice.
Oh, okay, good.
So it's closer to death. So yeah, advanced time period. So Daniel, do you want to stop? That is true. Every second we are closer to death. Every day you don't eat food properly increases the chance of you dying. I don't know, something like that. Right. You know, the animal class has the check of other factors. Shut up, back here. Right. Overridable, where did it get overridden? Well, let's have a quick look. Nope, I don't want to search in now, I want to search in here. So, overridable function, check if killed by the factors. That's an interesting one. It's not actually replaced anywhere within this code. But this code is very nice because it's basically set up to be overridden. So in object-oriented programming, good practice is to override or make all of your methods overridable if they're inherited by subclasses so that they can override them in special cases. So, for example, when I was doing my particle accelerator program, I made a base particle class, and all the functions were overridable, so that each function could do it. Yeah, there you go, polymorphism. That's the trick. So while none of these are actually overridden, I don't think they can be, and it's very possible that in the exam we'll be asked to create a new subclass of animal, like an eagle or a whatever, and have to override one or two of the functions. Yeah, stuff like that. I'll go through some. There is a specimen question that asks us something like that. So an overridable function means that so this is the base class. So overridable function, for example, check if dead or whatever. In the fox class, or the rabbit class, which inherits from that class, I could make. Oh yeah, in fact, here we go. This is the example. Overrides sub inspect, which means that the base class uses the same name. The subclass, sorry, uses the same name, but runs a different program. So it overrides the instructions here. So whatever happened, so whatever was written before in inspect, so doesn't occur. Instead, this occurs. Whereas fox might just have it inspect as the base animal class. Yeah. Does that make sense? I'll take silence as a yes. No? Ish. Yeah, don't worry about it too much. I'll go over this in more detail in a bit. Right, not the time Adam. The name confuses me. Where was I? I was advancing time period. And our foxes advanced to generation. Right. So yeah, we reached the end of that. So Fox needs food to eat to survive. If not, doesn't get enough food, then ages an extra time period. So basically brings it closer to death. Right, so when we were advancing our time period, so we advance the generation of our foxes. We check if the fox at that location is dead. If it's not dead, if it is dead, then we set that location to be 0, to be nothing, so the fox is no longer there, and the fox count is decreased by 1. If that location.fox.reproduce this period, then this. So there's another function. So this determines whether the foxes reproduce, which is a bit bizarre because I don't know if it relies on there being another fox to exist. Let's check. I can't remember this bit. Right. So public function reproduces period. So it's a boolean. So it either does reproduce or doesn't reproduce. So generates a random number between 0 and 100. Finds the reproduction probability times 100, and if it's less than, then it does reproduce. Otherwise, it doesn't reproduce. The reproduction probability.
I think they reproduce asexually, right?
Is that right? Foxes, yeah, they do. They do in this program.
Yeah.
Not in real life, so it's a bit strange.
Yeah. They're self-inseminating.
They're hermaphrodites. That I get, yeah, possibly. I don't think they will ask you to do that because it kind of changes the whole dynamic of the game. I don't think they'll ask you to change it because, like, the game's supposed to be able to run with like one fox against X amount of warrens and stuff. Sorry, simulation, whatever. Anyway. Right. So the reproduction probability is set as 0.25. 0.25 times 100, so 25. So it's got basically a 1 in 4 chance of reproducing, a 25% chance of reproducing, otherwise it doesn't. That was a CS:GO joke. I'm not within this. I'm not in that community. I'm not aware of these banters. I'll just stick to my sad life. Right. We advanced time period. I don't play Overwatch either, so. Right. Wobble-lubba-dub-dub. Hell yeah, Yu-Gi-Oh is better than everything. Right. No, it's distracting me. We don't have long. 20 minutes. Let's finish this. So there's a 25% chance that a fox reproduces in that time in a time period. If it does, then if show details, then a fox has reproduced. Presumably, I'm imagining that a fox really represents like a den of foxes, and then the dad is the only one that goes out and hunts and then mates with the female. I don't know. You can think about it like that. And so the new fox count is increased by 1. You can say something about gender politics or something. If show detail, then inspect the fox, so that just does the same thing. And if landscape xy dot reset food consumed, so that reset food consumed just sets the food it's consumed to 0 so that it can start again for the next time period. So that's what happens when a fox happens for the foxes. If new fox count is greater than 0, so if a fox did reproduce, then if show detail, then it writes new fox is born. And for each new fox born, create new fox, which we've already seen the subroutine for. If show detail, then console.read key. So and if draws the landscape again. So at the end of the advanced time period subroutine, draws it again so that the user can see, and also draws the menu with all the options, etc. And that advances the time period, and that's the main chunk of the code, which is good. So basically, everything that happens, so foxes dying, rabbits dying, foxes getting food, reproduction for both animals, all happens within advanced time period. So that's what happens when you advance it. If you, so those two menu options. If you select option 3 or 4, where you inspect a fox or inspect a warren, it asks you to input the X and Y coordinates of said fox or said warren that you want to inspect, and then it just runs the inspect routine again, so you can just see what's going on there. If you choose to inspect a warren, it will also ask you whether you want to view the individual rabbits, and if you say yes, then it does this little subroutine called list rabbits, which basically just lists out the information. Harshev, that screenshot he showed earlier with all the IDs of the rabbits and stuff, I believe was from that. Yeah. Yeah, we can. In a minute. All right, give us 1 minute to just finish this up. Oh, that's sad. Right. Well, tell us when you go, and then really quickly. No more time. Quickly, hurry. Right. So that loops and that ends. If the menu option is not equal to 5, then it keeps looping while it hasn't received an input. So that is what happens there. End sub. So the simulation ends, and then the code ends.
Yeah, once the simulation ends, you go back to the main menu, right?
Yeah.
And then you start all over again.
Thing is, there's no ending condition.
Oh yeah. Yeah. If the simulation runs on its own, then yeah.
Yeah, so it loops while. So this whole thing, this process loops while warren count is greater than 0 or fox count is greater than 0, and menu option is not equal to 5. So it'll keep displaying the menu and keep going through this whole thing as long as there are still foxes and warrens on the screen.
Yeah, it does. It's kind of unlikely in the current circumstances, but if you were to do a custom game, then yeah, if you had reduced reproductive rate, it would.
I've never seen the game end properly, so that might be a thing they ask you to do, put in proper ending conditions. But basically, that's the whole code. We went through it, guys. We did it. Reddit, boys.
Yeah.
Hey.
Yay.
Thanks, John.
Right, do you want me to... right, Arvin's going to go then, so is there any point me carrying on? I could show you like a sample. Well, what I recommend you all do is have a look at the... Yeah, the last bit is tough. But if you check the specimen paper and stuff, check the paper 1 specimen paper for all the questions that they might ask, because there'll be that sort of thing. Okay, stream end, DFTBA fam squad, keep it creaming.